Difference of two squares, example 1, something very simple. A squared minus b squared. Here's the first square, second square, and the negative sign between them indicates the difference. Well, what do we have in the brackets? A and A multiply together to give us A squared. B and B multiply together to give us B squared, and the interesting thing is that we have different signs in the brackets. Why is that? Well, if I expand the brackets, A times A is A squared minus AB plus BA, or I could write that as AB. BA and AB are the same, and then minus B squared, and the positive and negative sign in the signs in the brackets mean that the two middle terms cancel out. So we're just left with A squared minus B squared again. We can make this a bit more complicated. X squared minus 36. What we should realise is that 36 is a square number, so we can write it as 6 squared. And there's our second square, so we can then move to the brackets. X minus 6 and x plus 6. Example 3 is just a little bit more complicated again. 25 is a square number and 81 is a square number. What we can then do is, I'm going to write 25x squared as 5x all squared minus 9 squared. So brackets 5x, 9 and 9, signs are different. Example 4 is an interesting one because the number 2 is not a square number and the number 32 is not a square number, and yet it looks as though it might be a difference of squares. Well, what we should realise is that we should always look for a common factor first, no matter which type of problem we're working with. And I hope you can see that we have a common factor of 2. So if I take out 2, then it's going to be 2 times what gives me 2? 2 times 1. That first term then will be a 1 minus 16t squared. Now I'm sure you'll agree that 16 is a square number, but we mustn't forget that 1 is also a square number. 1, 4, 9, 16, 25, 36, 49, and so on. So 1 is the first square number. I'm going to have 2 further lines of working. What I'm going to do is I'm going to write the 1 as 1 squared. I'm not changing the value, but I am changing the appearance to make the square clear. I'm going to write 16t squared as 4t all squared. Final line of working, I've got 2 brackets. You'll notice, I hope, that the common factor of 2 appears in each of the lines of working. We don't forget that. So first term in each bracket is 1, second term is 4t, and then different signs. It doesn't matter whether we've got positive first or negative first, the signs must be different. Now, example 5, last example. What we should always look for is a common factor. Now, we might be tempted to say the common factor is x. Well, it is, yes, but there's also a number common factor here. In spite of the fact that 4 is a square number and 100 is a square number, I hope you can see that 4 is a number which is common to both. So what I'm going to do is I'm going to take out 4x as the common factor. 4x times what gives me x cubed? 4x times x squared minus 25. X squared minus 5 squared, and then 4x, two brackets. This is the final line of working, x minus 5 and x plus 5. That's it fully factorised.